I wanted to show the parts being printed now. I finally got things straightened out and I wanted to show you what the part looks like. This is a top-down view, if you would, and what you're seeing here is sort of like this cavity inside this smoke. See, there's a cavity in there. That's what you're seeing here, is the empty space that the smoke, the little fuzzy stuff will go in and there'll be a lid that will screw on top of that and seal that off. And there'll be a little hole down here, and that's where the smoke will come out, so you're looking down on it. And so what I'm going to do is rotate it. I got this little rotator thing. And I'm going to show you the different views. So now you can see how that's a deep chamber. And there you can see where the smoke fan would bolt into. It would slide in there. Remember, the fan is on a plate with a motor attached to it. I've already assembled it, so I can't show it to you, but at any rate, it will do that. And there'll be bolt holes in the four corners. I can put those in anytime. Then you'll notice there are two openings, and one is kind of up into the cavity a little bit, up into the circumference. The outer layer is the layer that gets pressurized. The inner hole here is sort of like the entrance of air to a tornado, okay? So this fan is going to spin pretty fast, and it's going to try to throw the air out. As it does that, it creates a low pressure vacuum in the center. So it's going to be pulling air in and pushing it out. When it pushes it out, this circumference is pretty tight except for this one spot. And that tight spot actually is a little bit of a cavern and then a hole. So the pressurized air will go through that hole. It will come in this hole. What that hole connects to is a side vent. You can see here, there's the opening of that same hole, and this is exposed side vent. And as you look through here, you can see straight through the part. That's because there's two side vents, one on both sides. And I can show you that in a really cool tool that we have here called Inspect Section Analysis. And what happens here is I can tilt it down a little bit and I actually walk through my part. I'm walking down, there's the top on the left, is the top. That's where the pressure will collect. Now, I'm going through, now I'm pulling air in the center, pulling it through, now I'm pulling it through those two rams on either side. I'm pulling air through the top and the bottom. But I'm not connected to that main circle on the left. You notice that? That main circle on the left just goes right through and keeps going. Now the cross sections end. So that's the bottom of the line. It's the end of the line for that hole. It ends. It has these openings and then it ends. So it's going to be pulling air through the sides, filling this chamber. The fan spins, pressurizes the air, sends it over here, and shoots it down this hole, and this hole ends up into the smoke chamber. And that's the smoke chamber right there, that whole width of it. So that's how that works, or it's how it's going to work, we hope, right? And get back to my rotate tool. And then you can see there's the sides again. Here's the smoke chamber, and that's the outlet. And if you look, if I line this up just right, you can actually see all the way through. So the fan is going to push air through here into this area. We're going to have a lid on top, and it's going to have a little hole, and that little hole is going to stick out right here, and that's going to be right under the smokestack on the engine. That smokestack right there. So it's not scaled right, okay? I can do that, but I'm not doing it right now. If I scale it right, shrink it down, even more so, it's too big, shrink it down, oh, even smaller, yes, more like that, I think, yeah. It's going to fit inside here, right inside here. I think it's going to be awesome. This is about the size of the original one, and it's really a little smaller than that. So I'm hoping that I've got this thing nailed and it's going to work for us. And I just can't wait to get this thing off the printer. It looks like we have some time left, 49 minutes left to print. It's, I think it's going to work. I think it's going to be compact. And then on the bottom, if you go to the bottom side, look at that, perfectly smooth. Oops, I'm not showing you. Perfectly smooth on the bottom, which means that could sit flat like in a building, or I can use my adapter plate like I had on the other engine, wherever it went. It's around here somewhere. I don't know what I did with it. Oh, it's over there. Or I could create an adapter for a different engine, a different footprint. So whether we have this is the Pacific with the mounting here and the boss and all that, 3 axles. The two that are exciting for me are the ones that were never smoke. They had the reverse in the boiler, so they don't have anything here. They have one hole to screw to, and that's it, and the whole surface is flat. So all I would have to do is flatten this out with a little piece of shim, and I could bolt that smoke unit right to this. The same here. Right there's 2 little holes. I can bolt that smoke unit to this unit, and even though it does not have a gear to drive any smoke, it can have smoke with a fan. Now, because we don't have a gear, it's going to be harder to put in the gear like we show here that rotates and triggers a switch, and that's used in this controller to create what we call the chuff trigger. The chuff trigger here is going to be set by this PC board. What this PC board does is it counts stripes. As the stripes go by, it counts them. And what we do is we calculate how many stripes does it take to make 1/4 of a revolution, 90 degrees turn of the wheel. How many stripes have to pass? So we calculate that number and we send it into this register. And let's say it's 90, just for easy thinking. It counts to 90, and then it sends what we call a trigger. It's a little pulse of energy to another control board, like this board here, that says fire. And when it says fire, what that means is it's going to send a little piece of energy to that fan to say turn. So it's going to go puff, puff, every time that cam hits that switch. Every time 90 stripes pass him, he's going to send a pulse to the fan that says turn, turn, turn. And every time he turns, there'll be a puff of smoke coming out the top. Poof, poof. And when that smoke comes out, sucking air in here, compressing it and pushing it out the front. Puff, puff, puff. Little motor is sticking out the back. Puff, puff, puff. Just like this. Puff, puff, puff. The difference with this unit is I put the opening for the inlet on the bottom because it was just a little easier for me to do that. And it's a very tiny opening. This is about half of what I'm going to have on the new one. And on the new one, they're going to be 2, one on this side and one on this side. So you're going to have 2 openings. You won't have the brass rod. In fact, this whole thing is all one piece molded. All one piece molded. You couldn't build this part. You couldn't conveniently or easily build this part without 3D printing. And I'm printing it like this. Take the motor off. And I'm just printing it just like that. I'm going from here, and I'm just going like this pen is pushing down ink. And when I come to those openings, I just skip that opening, and I go to the other side, and I keep putting ink down. I keep putting ink, filament, plastic, and I work my way around. Finally, I end up at the end, and I'm done. And then I pop it off, clean it up, drill and tap 4 holes, bolt my motor and fan in, throw in the heater and the foam, and go test it. You bet. Now, with the smoke and creating the heat, the challenge we have with that is, I think if I had